And then I'll have you, I guess you already said your name and everything, didn't you?
Yeah.
We can just kind of start in. Okay, I'll tell you when I'm rolling.
Oh wait, let me take this.
Okay. All right, I'm rolling.
All right, so we're gonna go over how to get a contact image. Let me just, oh, you're actually gonna have to start over because this thing was already on. All right. Just,
When you do that, are you going to, if there's certain little tiny menu items that you're doing, you might start to do it and then stop and tell me where you're going to be on the screen and I'll zoom in on that.
oh, okay. Like, okay. So first thing we're gonna do is contact mode, and we'll go over the steps of how to do contact mode. Of course, have the computer on first, then turn on the controller with the switch that's right above the power plug, and we went over this. It's right here. After you turn it on, make sure all the LEDs are on the controller. And that will show you that all the power supplies are operational. Afterwards, come back to your monitor and turn on the WinTV icon right here. 2000 on first. So double click that and you'll have a little video monitor. And this is the video coming from the head. Right click it to get rid of the borders. After you have the video on, now you can turn on the software, SPM Lab 604, which is right here. So double click that, and then the software will appear on the right screen. Of course, click accept. After you accept, you get a blank window. And there's an icon with like the cross section of a probe and a sample. Click on that to go into real-time mode. So we click this one here.
Show me that again.
Click on the real-time icon, which is the cross-section of a probe and the sample. And now you have a scanner selection window. First thing you want to do is select the CASW lin file, which is the software linearized file, because we're going to first, and click OK. Engage. Yeah, we're going to first balance out the resistor on the brick of the caliber to the resistance of the piezos from the head. So on the side of the brick here, there's an X, Y, and Z hole. Inside those holes, there's some potentiometers that we're going to screw in and out to change the resistance and to match the resistance that the piezos are giving out or reading out. And we're going to use a tiny flathead screwdriver. To look at the numbers, we go to Setup, XY alignment, and right now we're reading 1.71%. And I already forgot that before you do this, click close, sorry. Go to scan range and change it to 1 micron to center this X and Y piezos. Then go to setup XY alignment. So we're reading 1.8, 1.7 volts. We want those to read 2.3 volts. So we go in here with the flathead screwdriver and adjust your X resistance. And your Y resistance as well. And that's fine, plus minus 100 millivolts is fine on that. So with the software file, we can only do X and Y balancing. We do Z when we use the hardware file, which is a linearized file. So we'll click close. After that, we're going to switch over to the hardware file by going to setup and then scanner select. High voltage will be switched off, of course. click continue, and then click on scanner changed. Now we can choose the CHW lin file, the hardware linearized, and then click OK. OK again, and then engage. All right, so we did X and Y, now let's balance out Z. So go to Setup, XY alignment, again. It's reading 1.5 volts. We want to read that as close to 0 as possible. So again, we go on the brick and adjust that till it reads out 0. You gotta be really careful with the pots on the brick here, because you can push them hard enough to where you can break them, and if you break them, then you buy them. So we'll click close and we're ready to begin getting ready for contact mode. So the first thing you want to do, if you have the head, is screw in the head, the 2 manual translation screws all the way in, so screw them in clockwise. And then flip the head over. Now, grab a probe, and you could slide them out using the hole on the half moon pucks to the edge, and then grab it from the edge. So once you grab it from the edge like that, bring it over to the head. The 2 magnets on the Z scanner here will grab onto the half moon pucks, and then there, let go of it. After it's held on there, you can either use your tweezers, or if you're really careful enough, just focus on just the corners of that half moon to place the probe right in the center. So center it. Make sure it butts up against the back of the scanner. And it should look like that, nicely aligned.
Can I get a shot of that nicely aligned? Okay, start with the words nicely aligned.
So it's nicely aligned. So after you have that placed on there, turn the head over, make the cables face you. That way the motor is actually on the other side of the head. That way you don't confuse which one is the motor and which ones are the manual translation screws. You place the motor screw on the circular part of the XY translation stage first. After you do that, put the right one on the right leg on there between the 2 bars that are, move the X translation down on there, and afterwards you can just let the left leg just go down, and we keep a safe distance between the sample and the probe. All right. Next thing we want to do is go into the software. We want to turn on the laser right here. Set it to high. Low won't do anything, won't work. So always set it to high. Now we can't see anything on our video screen. So using the left and right knob here for video, we can adjust it to see where we can see the probe. So we'll get more like there. we're too far from the surface to get the reflective light onto the probe. So we'll have to bring down both screws, both manual screws, at the same time till we get closer to the surface. So we'll be able to see something. So we brought it a lot closer. Now we can see the probe right here on the edge. So again, we'll move the left-right adjustment for the video camera and center it. Make sure the probe is centered. And give you a better viewing angle. And now on the top screw right here, the focusing screw of the camera, we'll use to fine focus the probe, which it is now. So after we got it focused, we have it centered, we can lower the stage even more using the 2 manual Z translation screws. Again, remember to move them at the same rate. That way you maintain the head level. And then once you get close enough to the surface, you'll see the shadow of the probe on the sample. So get the probe close and to be about 2 lengths of the probe of distance apart from each other. So we'll get it close, but not too close. Or at least a probe length. Right about there. Now, we can see the laser on the surface right here. If you can't see it very well or you want to improve it, you can lower the illumination on the head by going on to setup and then going to video. A video window will pop up. You can drag that across to where the video is and you can change the bulb's brightness so we can lower it a lot more to where the laser's highly visible. Now, the next thing we want to do is move the laser to the probe. So you want to make the laser hit the tip of the probe so it can reflect off of the probe. So to do that, we'll use the 2 laser knobs. They're right next to the cable connection to move it around. So you push those 2 in. Sort of bring it to the probe. After you've moved the laser onto the probe, pull out both knobs. It's kind of like to disengage them. So this is how your probe should look like when you hit the tip of the probe. You can see the laser kind of illuminating the edges of it, and most of it's being reflected back onto the photodetector. Now, after we know that the laser's hitting the tip of the probe, we want to go back into the software and right below the laser adjustment, there's a detector signal kind of box. Click on some.
Say the word, click on some again.
Click on some.
Yeah.
So I click on the sum button. I'm gonna make this bigger. So after we click on sum, we see that we actually have something more than 0. So we left click on the oscilloscope window here, which is the sum window now, and we see that we have 27, which is pretty good. So after we see that we have a pretty good sum, we'll try to improve that by moving first, leaving on the sum window and pushing down on the top of the head to keep the head stable, and then moving the top bottom knob, which is the big knob right here on the side of the head. So push that one in and adjust it. So you see the highest number of sum you see, the highest number you see here, which is the highest sum you can achieve. So right now we're seeing 34 now. So we'll adjust it till it's at its peak. Which was about 35 and a half or 35.7. Right click the oscilloscope, click on the detector signal, the left right button. Now we see that the alignment on the left right is way at the bottom. So you want to bring that up. To do so, we use a little knob with the left right adjustment knob. And if it's at the bottom, turn it clockwise to increase it or raise it. And we want to get that one till it's 0. And not only that, you want to make sure it goes through 0. So we might be able to get to 0, but you want to be able to make sure it can go through it and go beyond 0. So after you verify that it can go through 0, bring it back down. Leave it at 0. Afterwards, go to the top bottom signal, click on that, and you'll see it's capped off at the top. Same thing, only using a different knob. Use the top bottom knob, and since it's at the top, go counterclockwise to bring it back down. And this one's very sensitive, so I brought it way back down too fast. So I gotta go back up top. And just like the left right one, make sure it can go through 0, which it did. So look at that.
Can you show me again on the screen what you're talking about?
So we want to make sure that this line goes through 0. See it going down. And that's the alignment of the photodetector. You want to make sure that the top bottom signal is at 0. There. So now we have placed the laser on the probe, reflected the probe laser, the laser off of the probe onto the photodetector, and aligned the photodetector to where the laser is right in the middle. Now we're ready to engage. But before we can engage, we have to set up a set point. To do so, we'll go to the set point menu here, highlight it, and for a contact probe like this one, we'd probably see like a 30 nanoamp deflection. To put in 30 nanoamps, let's illuminate the image a little bit more so we can see it. Afterwards, let's bring down the head closer to the surface using the motor. You can do that by clicking on the down arrow here. By manually bringing down the head closer to the surface, you lower the waiting time for engaging. And then it looks like lowering actually affected the laser alignment. So we go back into the top bottom signal and bring that one back down to 0. So we're moving down to 0. We have 30 nanoamps as our set point. Scan range right now is 1 micron. We'll do a 50 micron scan size just. And scan rate could be between 3 and 4 times the scan range. So 3 times 50, 150 microns per second. It can handle up to 200 microns per second. Resolution is 300, so 300 points per line. You can bring that down on the drop-down menu, go up to 1,000 points per line. Proportional gain is 10. This could go from anywhere from 0 to 100, depending on how your tracking is. So to improve it, increase proportional. If you start to oscillate, maybe lower it a little bit more. Integral, the most sensitive gain of them all, I guess. Integral gain, you'll probably keep between 0.1 and 1, if that. Derivative gain, if you see oscillations, we won't usually see any oscillations in contact mode, so you'll put this one to 0. Now, a good proportional integral gain would be to start with is 0.5 and 5 and 0.5. 5 for proportional, 0.5 for integral. All right. So we're well aligned. We got a set point. We have our scan parameters already set up. Now we can approach. So to approach, there's a tip approach button right below pre-scan. Click on it, and it'll automatically approach till it hits the surface and sees a 30 nanoamp deflection on the probe. And you can see it, the deflection changing on the top bottom signal. All right. As we engage, we see a little bit of noise on our top bottom signal. So you see this. So to reduce that, we'll first reduce the integral gain to like, let's see, 0.3. See if that helps. Not so much. 0.1. And that one helped a lot. So 0.1. Let's try 0.2. Let's see if we can get away with it. Yeah, that's okay. So we're engaged. We don't have that much noise. Now we can scan. To scan, on the menu, there's these arrows going back and forth. Click on those to start a scan.
Let me have you say that again. Okay, go ahead and start.
So to start a scan, you go to the, on the menu you go to the left and right arrows right here, which is right next to a stop sign, and click on that, and it'll start scanning. And you can see on the video monitor that you're actually going back and forth, and you're actually scanning. And that's how to engage in contact mode. That's it.
Great.